Greetings and welcome back to the lab. As you can hear, I've got an oscillator going in the background. This is the breadboard of the first oscillator for the Redtronome project, and I've been doing some experimenting to try and find something, to find the right combination of resistors and capacitors that will work. I've done a bunch of calculations, and what it ends up coming down to is the calculations will get you in the ballpark, but you ultimately need to do something to actually try and build it yourself. And I think this is pretty close. I'm going to do a little bit more experimenting on camera here, but just to give you an idea, this is supposed to be the 1/3 hertz, or actually 1/3 cycle. In other words, one beat every 3 seconds. That I thought was going to be a lot harder to do, but actually it turns out it might not be so bad. It turns out that that's actually 1/6 hertz if you look at it in the last video. But let me go ahead and play my reference, which is tuned specifically to 1 tick every 3 seconds. Okay, that's slightly before. Now it's almost on. Now it's a little bit, now my reference is ticking before this, which means that this is a little bit too slow, I think. Let me do that again. The tricky part is trying to sync this up. So I'm going to stop it, and then on the next beat I'm going to try and anticipate and turn it on. Here we go. They're in time. Now they're out of time. Okay, so this is too fast. And so the trick here is I've got 2 trim pots, and the idea was what I'm trying to do is tune this carefully. I'm trying to get as close to the ballpark as I can with the first one. Made a slight adjustment. Now they're way off, so let me try and resync again. Okay, slightly before. Slightly before. A bit more before. Oh, maybe catching up. Yeah, catching up. So this is still just a hair too fast, but you kind of get the idea. And then what I can do with this, move it just slightly, ever so slightly. Now I need to resync again. Reference is a little before. Still not quite there. Too fast again. So, but that'll give you a rough idea. Now, the other trimmer is supposed to be there to give you even more fine tuning. So in theory, I could turn this and it would allow me to speed it up or slow it down by just a little bit. This is a much smaller trimmer than that one. So the idea is that I could tune it in. Unfortunately, what's happening, I don't know if you've already heard it. Let me go ahead and let this play. And I'm going to turn it more. You hear that double beat? I think what that is actually the duty cycle, which I was expecting to be around 50% based on calculations, but it sounds like it's pretty far off. Now that could be a feature if that's what you want. Now the reference is only a minute long, so I've gone long enough on this, but that gives you an idea. I'm close. I'm going to do a little bit more experimenting, and then I'll come back and we'll see if I got it close. And then once I get it close enough, and pardon the avalanche. I got a lot here. I'm going to have an avalanche before too long. Once we get it really close, I'll be able to actually put the first oscillator right down here. Oh, sorry. Have it upside down again. I'll be able to put it right down here. The chip goes up here. The capacitor goes here. One resistor goes here, and then I've got the two trimmers. I also have the ability to run another resistor in parallel with that first trimmer, which helps me to get in the ballpark a little bit easier, although the calculations are a little bit more complicated. So let me go ahead and try this a little bit more, and I'll come back and we'll see where we are. All right, I'm back, and I've discovered or relearned something. Let me stop my reference here, and let me see if I can't try and sync this up a little bit. Almost in sync. I'm hoping that's coming through. Let me try turning it up a bit. Okay, it's a little bit slow, but the other thing that I remembered is that this is the whole thing with it being a square wave with a duty cycle, and if the duty cycle is not 50%, if it's not spot on there, then the period between one tick and the next, and then the third one, doesn't match up. So it might seem like it's going fast while you're trying to tune it, and then you try and slow it down, and then the next thing you're going too slow. You got to give it 2 ticks to see if it's matching up. Now right now I can tell it's drifted out of sync already, and it's been less than a minute. But I'm getting closer to figuring this out, and then we'll be able to build. So I'm going to do a little bit more experimenting, and when I finally get it locked in, or close to lock in, it's not going to be perfect. But I'm basically thinking, okay, the typical song is 3 to 5 minutes, you know, like something with a real beat to it. Is not going to be too terribly long unless you happen to be Pink Floyd. Then if I'm thinking 3 to 5 minutes, what I can do is extend my reference out to 3 to 5 minutes and use that against this oscillator. And if it doesn't drift too much over the course of, say, 5 minutes, then we're probably okay, because there is a facility in this system for synchronizing the oscillators. So they'll all start at the same time, and then it's a question of how much they drift relative to one another. So that is the plan. I'm going to push forward with this, and I'll be back when I've got the next part of this figured out. Okay, I'm back, and as it turns out, there was one mistake that I made. I was really surprised that I made, but it turns out on the circuit board there is room for R1, but then there's also R2, which is made up of 3 parts, 3 resistors in series. So the first one is a discrete resistor like I've got right here. And then what I was doing was I had the second position here and the third position there. So it was basically one resistor to get me close, and then the second resistor was considered coarse tuning, and then the third resistor was fine tuning. Well, I just said it the way I was thinking it, and if you didn't catch what happened there, that first resistor is R1. I need the first part of R2. I completely missed that. So I've added in a 33K resistor here, and then I've got on top of that well, what did I put in here? 10, yeah, oh, that's right. That's a 10K resistor. So a 33K resistor is actually supposed to get me in range, but if you consider the fact that this capacitor could be out of spec, I mean, it should be in the neighborhood, but it could be 10% tolerance. And that first resistor, R1, could also be 10% tolerance. So I need to add enough resistance on R2, part 2, or R2A, B, and C. Let's call it that. On R2B, I need to add enough that I can dial it back if I need to get towards the 33K, or I can go up further. So I can go to 35K, I can go to 40K, I can go to 43K. So it really is a question of how much tolerances you have, and then trying to match that up with the resistors and the potentiometers, the variable resistors that come in after it. So that was the whole sort of, the mistake was forgetting to put in part A. So I got that in now, and you can probably hear it ticking. And I can't turn it up, so I wanted to... I'll just pause. So hopefully you can hear that. That should be somewhere close to once every 3 seconds. So I'll demonstrate by playing the reference off the computer. Let me turn that up a bit. You can hear it drifting out, so that's the problem I'm having. It doesn't seem like it wants to stay stable. But I've got these resistors set up in such a way that if I turn it to the right, it goes faster. If I turn it to the left, it goes slower. I think I'm close enough on this that I can go ahead and put it on the circuit board. But what I'm curious about now is, can I use the same set of components to also give me 1 tick every 2 seconds and then 1 tick every second? And I think I can do that with the coarse tuning. So if that works, that's what I'm going to try live here. Well, live to tape. So let me stop this. And let's go to once every 2 seconds. And I'm going to try and speed it up. Or do I have this backwards? Let me try turn it all the other way. No, I think I had it right. So if I turn it all the way that way, no, not quite there. So I'm going to have to try a different approach for the next oscillator. But I think I've got enough of a combination to get the first oscillator in. Then I can breadboard and figure out what I'm going to do for the second oscillator. I'm going to go ahead and figure out all the rest of these the best I can to get like the first 3 or 4 oscillators together. And that should give you enough information that you understand how to tune all 8 of them. It's going to be a little bit different when you go from the really slow to going to faster stuff, but this is the metronome, so everything is staying pretty slow. So I'm going to go ahead and try and do that, and I'll be back. And we're back, and another revelation. This time I put 3 of these variable resistors together to equate to the 3 positions that I was attempting to do before, which allowed me, basically I went with 100K, 10K, and 100 ohms. And that allowed me to do a very coarse, and then a coarse, and then a fine tune. And what that revealed was that the numbers were different than I was expecting. And it's pretty close. So let me play a little bit so you can hear it. There's a little drift, but it's pretty close. Okay, now it's drifting further away, and I'll have to address that. But the other thing to consider is the duty cycle for the for the waveform, which if you think of duty cycle, it's basically in a sine wave, you got something like that. And your cycle is when you go from this point rising up and then back down and back up again to the same point you started at. You do cross that point in the middle, but that is not always symmetrical. And so with a square wave, we're dealing with kind of the same thing, like that. So you're starting here, you're going up, and then you're going to cross that point, and then you're going to come down and go back up again. But what if your square wave looked more like this? Then obviously you have more time up above the line than you have down below the line, and you're going to hear a tick here, a tick here, and a tick here. These are not going to match up perfectly. So really what you need to do in terms of figuring out the cycle is look at this first point and that last point in the cycle. And that way if you can get every other beat to match up, then you're off and running. So that's where we are on this. The conclusion here, I was thinking it needed to be on the order of about 33K, plus or minus a bit, and so I was adjusting for that. But this turned out to be, this first one turned out to be 14.86K. The second one turned out to be at 8.3K. And the last one was 58.7 ohms. So total, this is about 22 to 23K with some tuning in there. So I was putting a 33K resistor in there. I should have been putting a 22 in there. That would have gotten me a lot closer, and I could have had smaller trim pots to be able to tune in. So that's where we are on this. I am going to do this. I've got this marked down now for, this is actually for the 1/2. I need to do it again for the 1/3. Once I got that, then I can start putting it on the circuit board, and we can see how well it works on the circuit board. And we're back with 1/3, which you can hear going in the background. And let me see if I can't play the 1/3 along with it. Okay, that wasn't very good. Let's try that again. So they're out of sync now, but we're close. Now remember, this is so slow that it's going to create problems trying to figure out kind of where you are, but I've discovered a couple of things, and I will say that when you go to test the resistances here, if you follow my model, and I will, I put the resistances here. I will put all the resistances for all 8 of my oscillators down in the description. It's going to take me some time to go through and do all the testing, figure out what's what. I am putting, I am taking the R1 and the C1 and putting them in bags labeled as 1/2, 1/3, 1, so on. Sorry, 1/3, 1/2, 1, 2, 3. Anyway, you get the idea. I'm putting them all in bags so that I keep the components that I was using when I was testing. That way I can use these particular numbers. But I discovered something else, in that when I was trying to measure the resistances, they kept kind of fluctuating, and I was going, what's going on? Then it finally dawned on me. C1 was charging and discharging while I was trying to test the resistance, which is going to screw with the multimeter. So I pull this out before I actually measure my resistances. So for reference, the 1/3 gave me 33.9K, a bit higher, 1.49K, and 85 ohms. I'm going to have to do the 1/2 again to make sure that when I pull the capacitor out that I get the proper readings. So I'll go ahead and do that. But this video, I fear, is getting a bit long. So what I'm going to do is I'm going to break here. I'm going to wrap up. And we'll pick up in the next episode with me starting to assemble it on the circuit board. If you were hoping to see the circuit board, I apologize, that assembly, but this is going to be a bit of a process, and I don't want my videos to be 45 minutes long, so I'm trying to keep them in bite-sized chunks. Bite-sized engineering, bite-sized chunks. There we go. So I'm going to go ahead and keep experimenting and get some of these numbers together, and then I'll be able to do a video where we start actually assembling it and testing it on the circuit board, and we'll see how well that goes. Thank you so much for watching. Stay tuned.